Hey guys, welcome to my channel. In today's video, I'm going to be talking about the histological structure of arteries. So in the previous video, I already talked about the general structure of any vessel in the body. Today, I'm going to be talking specifically about arteries, the different types, and the differences between them. So first, an artery by definition is a vessel that takes the blood from the heart right here. So let's say we're gonna go to the left ventricle. So it takes the blood from the heart to to the different types to the different organs of the body. And so this is the direction, okay? And in most illustrations, like in this one, arteries are colored in red, and that's because arteries most of the time contain oxygenated blood. That means blood that is rich in O2. But sometimes we actually have arteries that are colored in blue. And as an example, we have this one right here, the pulmonary trunk. It goes from the right ventricle to the lungs. And so by definition, it's an artery, but it's blue, and that's because it contains deoxygenated blood that is rich in CO2. Okay? Yeah. Now, arteries, generally speaking, not generally speaking, but arteries, they always transport blood at a high pressure compared to veins. So the pressure varies from 80 to 120 millimeters of mercury. So the 80 pressure, which is the lowest one, is called the diastolic pressure. That's because it is due to the diastole of the heart, which is the relaxation of the heart. And then the 120, which is the highest one, is called the systolic pressure, which is due to the systole. All right? Okay. Now, let's start. So the general structure, as I said in the previous video, we have 3 layers. So from the inside to the outside, we have the tunica interna or tunica intima, which is composed of an epithelium. It's called the endothelium. It's a simple squamous epithelium. And then we have a connective tissue underneath it. It's called the subendothelial connective tissue. And then we have the internal elastic lamina. And then the second layer, which is called the tunica media, which is the muscular layer. So it's composed of smooth muscle cells plus elastic fibers, which are not mentioned here, but there are smooth muscle cells and elastic fibers at different proportions dependent on the type of vessel we're talking about. And then we have the external elastic lamina. And then we have the last layer, which is called the tunica externa or adventitia. So this layer is kind of like a protection layer. Actually, it's been recently found that this layer actually has a function in inflammation, but yeah, it's basically just a connective tissue on the outside of the vessel. And then we have the vasa vasorum, which are these little tiny vessels that are destined for the blood supply to the vessel itself. Now these, we find them only in like big, large vessels. In arteries, the tunica media, the middle layer, is actually the thickest one. So this one is the thickest one. And if we section an artery, it will appear as very like round, okay? And the wall is pretty tight compared to a vein. Now, as the artery branches and as we move away from the heart like this, wait, I'm gonna choose another color. Let's choose, I don't know. Well, I don't like the colors here, but I'm gonna choose this one, I guess. So as you move away from the heart in this direction, you can see that the arteries actually branch and their diameter decreases. And as we move away from the heart, the structure of the wall also changes. And dependent on these changes, we have 3 types of arteries. So so these three types. So we have the first type, which is the arteries that are the closest to the heart. They are called the elastic arteries, and then after these we have the muscular arteries, muscular, and then we have the arterioles, which are the smallest ones. Wait, arterioles. Arterioles. So yeah, let's start with the first type. So the elastic conducting arteries. So these are the biggest in diameter. Obviously, their diameter is usually above 10 millimeters. They come directly from the heart. Their wall. Now these arteries, they're larger in diameter, but their wall is pretty thin compared to the diameter, and we're gonna see later how this is important. So these so if we wanna show their names, we have the aorta, we have the brachiocephalic trunk right here, we have the primitive carotid arteries right here, we have the subclavian artery. So it's only in the portion that comes before the scalene muscle. So here is the subclavian artery. Here there is the portion that comes before this muscle, which is the anterior scalene muscle, and then we have the portion that goes behind this muscle, and then we have the third portion after this muscle. So this portion before the muscle is the one that is elastic. Okay. And we also have the internal thoracic artery, and of course we can't forget the special one, which is the pulmonary trunk. Okay, so this one, which is not showed in this picture, but it's right here. Okay, yeah, so these are these arteries. Now for their structure, what is special about them? So as you can see, we have the three layers. Now the special part is actually the media, the tunica media. So I said earlier that we have smooth muscle cells and elastic fibers. These vessels, these arteries, elastic ones, they have way more elastic fibers than they do have smooth muscle cells. So yeah, now this is super important. Why is it important? Well, the fact that these arteries walls is so elastic is very important because they act like capacitors. Now if you think about it, these are the arteries that are the closest to the heart. So and the heart actually contracts and then relaxes. And so when the heart contracts, it pushes blood to these arteries that are very close to the heart. And what that means is that the blood pressure here is very high. And these arteries, because they're elastic and their wall is pretty thin compared to the diameter, they're gonna distend. Okay? And then when the ventricles relax, the blood pressure is gonna be lower. And so these will actually recoil and they will push the blood. And so when the blood rises too much, they will actually try to compensate for that by increasing their diameter. And when the blood pressure decreases, they will recoil and push the blood. So they will compensate for that decrease in blood pressure. And this has a dampen effect. Dampen. Now what does this mean? It means that they decrease the fluctuation of the blood pressure over the cardiac cycle. So instead of having the blood pressure inside of these arteries going like this, so here we have the systole and here we have the diastole, the blood pressure goes like this instead. So it's more like there isn't like such a big fluctuation of blood pressure. And this is actually called the windkessel effect. So you gotta remember this. windkessel effect. I'm sorry for my handwriting again. And I actually have in the description a link to a YouTube video that really showcases this effect. It's really, it's a very a good video. You should check it out. It's in the description. Now let's talk about the second type of arteries, which are the muscular distributing arteries. So these are obviously smaller in diameter. These have the highest number in the body. So these go from the elastic ones. So we go from the elastic arteries to the inside of organs. All of that is muscular distributing arteries. So their diameter ranges from 0.1 to 10 millimeters. The ratio of the thickness of the wall to the diameter is higher. So their diameter is smaller, but their wall is still pretty thick. So yeah. Now the difference with these is that the tunica media is very rich in smooth muscle cells compared to elastic fibers, as you might have guessed. And so these arteries really can contract and push the blood. And yeah, they're actually constantly, they are constantly contracting. So yeah. Now you might wonder, like, how do we transition from the muscular to from a muscular to from an elastic to a muscular pattern? Well, this happens in three ways. So this can happen abruptly, which means it happens suddenly, as it's shown in this illustration right here. So we have this transitional zone, and it just happens super like suddenly. So here in purple we have the elastic sheets, and in pink we have the smooth muscle cells, and we find this kind of transition in the celiac trunk. Okay. Or it can happen progressively, and it can happen in two ways progressively. Okay, so it can either happen by here by the smooth muscle cells segmenting the elastic sheets little by little. So this is the TZ, the transitional zone, and yeah. Or it can happen by having this internal smooth muscle layer right here, this one, that progressively gets bigger and bigger at the expense of this layer, which is the elastic layer. So yeah, so here it's small, and then it gets bigger and bigger and bigger until we have a muscular artery. So yeah, these are the three ways we can have transitions. Now let's go to the third type of the super small arteries, which are the arterioles. So these are really small. They're smaller than 0.1 millimeters. We always find them inside of the organs. These are muscular, so they have 1 to 3 layers of smooth muscle cells. And they're the ones that come right before the capillary bed, right here, and these have the highest vascular resistance because their diameter is super small and their wall is pretty thick compared to their diameter, so they have a lot of resistance, and they can contract and really regulate the blood flow to the capillaries. And actually, right before we go into the capillary, we have these things, okay, these smooth muscle bands around the vessel, and these are called the precapillary sphincters. So these control the blood flow that goes into the capillaries. Okay, so yeah, so I basically talked about the general organization. Like we said, we have elastic arteries, then they transition in three ways into the muscular ones, and then they go inside of the organs, and then right before we have capillaries, we have the arterioles. And yeah, now this rule applies basically to any part of the body except certain places where we have like special parts. The first example I can think about is the lungs. So here is like the lung tissue, a part of the lung tissue. Inside of the lungs, you might think that the arteries are gonna be the muscular type because we're inside of the organ. Well, not in this case. The arteries inside of the lungs don't have a lot of smooth muscle cells. They actually have way more elastic sheets. And why is that, you might think? Well, it actually makes sense if you think about it, because the lungs the lung tissue is very, very rich in elastic fibers, because the lungs have to expand, they have to distend during inspiration, and so do arteries. They have to distend with the organ, so they have to be elastic. Another example would be the coronary arteries that are destined for the heart. These ones, in their tunica media, instead of having smooth muscle cells, they actually have cardiac muscle cells, which is a very different type of muscular cells. So yeah, so you gotta remember that. For example, inside of the brain, we have these very small arteries that basically don't have any elastic fibers, because they need to not be able to distend. Okay, so yeah, we have certain places in the body where the rules don't necessarily apply to, but yeah, I think I talked about everything. I think I covered everything. I hope this video was helpful. If you liked it, please don't forget to leave a like, a comment, subscribe, the usual. And if you have a question, please leave it in the comments below. I will try to answer it. And good luck on your exams. And yeah, thank you.